All right, Matthew, when is the bug moving left? I don't care if you write it as an interval or if you do 30 is less than t is less than 55. Okay, Wyatt, why? How do we know that the bug is moving to the left? The velocity is negative. Thank you. That is exactly how I would like you to word that. Okay. When does the bug change directions, Henry? Austin, how do we know that's where the bug changes directions? What is it? Oh, because our velocity changes from positive to negative. In this case, you said also if the velocity changes from negative to positive, that would also indicate. All right, excellent. When does the bug have zero velocity, Kylie? Okay, and we know that because why, Connor? Okay, well, so we're at the t-axis on our graph, right? Okay, I mean, that one wasn't really as fabulous. When does the bug have zero acceleration, Dylan? Cole, why? Okay, so what's true about its slope? So the velocity has a slope of 0, which means acceleration would be 0 because accelerations are derivative. Okay, let me ask you another question. I want you to think about at time is 20. Is the bug speeding up or slowing down? Think about it in your head. Think about it in your head. Tiernan, speeding up or slowing down?
Slowing down.
Slowing down. Aaron, why?
Because the velocity is positive. Slope is negative.
Okay, velocity is positive, but acceleration is negative. Okay. Isaac, give me a time where the particle or the bug is speeding up. From 30 to 40, our velocity is negative and our acceleration is negative, so they match. Okay, cool. Thank you. We are going to, hopefully I don't get emotional here, take notes for the last time in calculus. Right?
Yeah.
Yeah. Okay. This is the last new information I will ever teach you in this class. I'm saying me, I, Mrs. Homan. This is the last time I will teach you a calculus lesson.
What if I like the last time?
Then I guess this wouldn't be the last time, but I just really hope that that is not your path, okay? All right, we know that velocity is the derivative of position. And we know that acceleration is the derivative of velocity, which is the second derivative of position, right? Like we've talked about this. What way do you think we're gonna go today?
Third derivative.
No. What did you say, Cole? Antiderivative. The position is going to be the antiderivative of velocity. The velocity is the antiderivative of acceleration. I love calculus. You're breaking my heart. Just pretend to like it, okay? Yes.
What's the antiderivative of position?
Nothing important.
But like, what is it though?
I mean, no, like there's nowhere to go from there. A jerk. You wanted me to say somebody's name? Okay. I thought we talked about that the other day. That's not have been paying attention. I think. Third derivative is a jerk. Or a Matthew. Hey, you said you could handle anything. Okay. I know, right? All right. Derivative. Wow. Okay. We are going to find the position function of a particle with velocity, cosine of pi t, and it's at the position s equals 4 when time is 0. Okay, if we're going to go backwards, we do need an initial condition so we can find r plus c. So I'm just waiting for you to copy down what you need to, and then we'll get going on our example. So our position equation is going to be the antiderivative of velocity. And see, I really like saving motion for last because we get to just practice everything. We get to practice derivatives, we get to practice antiderivatives. Okay. Nathan, what's the antiderivative of the cosine of pi t?
That would be sine. Oh, it would be pi sine pi t.
Think again about our coefficient. It would not be pi.
It would be the root.
Well, if we're going to take the, so we can think about this a couple different ways. We can think about u substitution. U would be pi t. So du would be pi dt. And we would have to divide over the pi to be the coefficient. Or you can think about if we go backwards, the derivative of sine pi t would be pi cosine of pi t.
Oh, I was
So we
thinking of
need-
it as it.
Okay. But there's something missing.
C.
Okay, there we go. So there's our position equation. Now, we know that our position is 4 when time is 0. So we're going to plug 4 in for position when time is 0. What's the sign of 0? Zero. Sign of 0 is 0. So our position equation is 1 over pi sine of pi t plus 4. Okay. Questions? Feels like kind of a review. We just attached names to our equations, right? All right, so let's do this one. I want the position function of the particle. If our acceleration function is this, and we know the position at 3 is h, the velocity at 3 is 2. Okay, go ahead and write it down, and then we're going to talk through what we need to do. How many times are we gonna have to take the antiderivative and find the plus c? Twice. We're gonna have to go from acceleration to velocity and then from velocity to position. So what I want you to do, I'm gonna give you 2 to 3 minutes to work at your pod together on getting to the position equation for me. Okay. Ready, set, go. Like,
At home.
like drop your cracker on this one.
Oh, not yet. Not I don't want
But they don't walk around with shoes. Right.
They do go outside.
but they don't. Yes. Oh.
Your plus C's and
What'd you get for C, what'd you get for?
would you get C, your C value for velocity?
What'd you get for C4?
8 of 34? Yes. No, I don't know. That just like,
For C value for position, did you get 1.75?
here's one group's work for V of T. Oh. All right, Henry and Isaac, what did you decide on for C? You haven't decided. You all three got different answers. Oh, this is not good. What did you get? Oh, what'd you get? On 80.75. All right, so you're telling me that your position equation is 1/4 t to the 4th plus 1/3 t cubed minus 34t plus, oh no, 80.75. That's what you're telling me. And does the rest of the class agree? You all four got 80.75?
Yes.
Cole, did you get there? Getting there. Okay, Austin, you got here? Okay. Julia, got here? Awesome. Okay, so a portion of your worksheet today, actually like the first, yeah, it is 12. Creepy. No, first 8, JK. 9, 10, 11, and 12 are going to deal with distance versus displacement. Okay, I feel like we all understand what distance traveled means, but what does displacement mean? So if we have a bug going right and then left and then right and then left and stops, displacement refers to what? When the bug stops at a specific time, how far away is the bug from the origin? Okay, so displacement is the resulting position of a particle after a certain period of time. Bless you. Allergy season is in full swing. Yep, with some snow. You know, I'm happy that we have school today. I really am, because we have to, I mean, we got to get through our material before you guys graduate. But I am really tired of this winter and spring having like snow that's enough to be annoying, but not enough to get school called. You know what I mean? How many times has this happened? Like way too many. Yes. Oh, I had problems walking in too. Well, I don't think they anticipated it. Okay, we did not get salt this morning because I almost fell walking in.
Car door almost got
But we all made it and we're okay. And you're going to be able to play soccer tonight. It'll melt. The sun is supposed to come out this afternoon. Yeah. Okay, so negative displacement. If I say, what's the displacement after t seconds? And that number is negative. Well, that means that we ended where? To the left of the origin. Positive displacement means we ended to the right. And 0 displacement means we're back at the origin. Now I'm actually I'm gonna erase origin. And I'm gonna change it with, instead of origin, it's gonna be for where we started. Okay, if I started here and I go right and the left and right and left, then our displacement is always gonna be in respect to where we started. Does that make sense? More sense than origin? Okay. Okay, so to find displacement, we are going to take the definite integral of velocity. Does it make sense why we're taking the definite integral of velocity to get our displacement? Okay, we're going back to a position first of all. Okay, a definite integral means we'd be taking the position at B minus the position at A. What's the difference from where we started to where we ended? I mean, that's what we're doing, right? Okay. So here we go. I want the displacement of this particle from 0 to 3. So just write down the example so you have it, and then we'll go through it together. So to find the displacement, we are going to take the integral from 0 to 3 of t squared minus 2t. All right, so what we have 1/3 t cubed minus t squared evaluated from 0 to 3. Getting pretty excited about this. We have 1/3 times 3 cubed minus 3 squared minus 0. What do we get? Ooh, our displacement is 0, which means we are back at our original position. Whatever that may be. Okay, we don't have to know anything about like initial condition in order to figure out what our displacement was. Okay, so wherever we were at time is 0, we are back there for time is 3. Did the particle not move at all? No, it moved back and forth, which means we could calculate its distance traveled. And the distance traveled would actually be a number that's not 0, right? Okay, so how do we figure out distance traveled? Okay, let's talk about what this graph looks like. Okay, so 0, 2, we have a parabola, and then there's 3. Okay, so what do you say about area? Okay, well, when we did our displacement, we took the definite integral, which means we calculated the area under the curve. This was negative area and this was positive area, and together they equaled 0. Yes. So to find distance, we got to integrate the absolute value of velocity. In order for us to figure out distance, we need to take the integral of the absolute value of velocity. Well, our velocity equation could be positive or negative. Where it's positive, that's fine. Where it's negative, we need to make it positive. So what we're going to have to do is we're going to have to figure out where is our velocity positive and where is it negative. Okay. So I drew a picture for us right here. I know that this has positive velocity right here. Okay, so we can have the integral from 0 to a of velocity and be fine. But this right here, this is negative area. So what I'm going to do is I'm going to subtract the integral from a to b of velocity, because I know that if this is negative area, so when I subtract it, it's going to become positive. Okay, so if I ask you to find distance traveled, we need to figure out where is our velocity negative, and we need to break up our integrals accordingly. We're going to come back to this same example. You know, the one where our particle didn't move. I mean, it did move, right? But it just ended up at the back at the same position. Okay. Now I want the distance traveled. It started somewhere and came back, but how far did it go? So in order to find distance, we need to take the integral of the absolute value of velocity. And in order to do that, we must know where our velocity is positive versus negative. Okay. So side note, when is our velocity 0? And from 0 to 2, our velocity would be negative. And then after 2, it's positive. Okay. So what we're going to do is we're going to find our distance by taking negative the integral from 0 to 2 of t squared minus 2t plus the integral from 2 to 3 of t squared minus 2t. Okay. Since our velocity is negative from 0 to 2, I took that integral and made it negative because two negatives make a positive. You can do this by hand, right? This whole time, gosh darn it, this is home. All right, what is 1/3 times 2 cubed? Eight thirds minus 4. Negative 4/3. So this is negative 4/3 plus this gives us 0 minus this gives us negative 4/3. So we have negative 4/3 plus 0 minus negative 4/3. That's beautiful. 8/3. Ooh, we can put a label on this. Meters. Go back to our bug. Okay, if I ask you for the displacement of our bug. Excuse me. Whew. Start calculating some area here. What is the area of this triangle right here? Three? What? 3? So this is 10 times 60 divided by 2. Okay, so this is 300. How about this sliver right there? Was it? Okay, and how about the next triangle? For what did you say? 450? Because we have 15 times 60 divided by 2. Is that accurate? Okay. How about this triangle right here? We have 5, 10, 15, 20, 25 times negative 40 divided by 2. 500. Yes. Okay. So our displacement, we're going to take 1050 plus negative 500. What's our displacement? To the right of our original position. Okay. Now, what about the distance traveled? We would have to take 1,050 and we would add 500. It's not nifty. What did you say? Thank you, Cole, for holding me accountable. You will have to remember it now. Yes. Okay, let's use your calculators. Get them out. We're not gonna worry about that. Okay. Find the displacement of the particle over the interval 0 to 3. So displacement is the integral from 0 to 3 of our velocity. Find it for me with your calculators. Well, what? 8.657 centimeters to the right. To the right of what? Of our starting position, which is actually 6. Okay. So its actual position would be 14.657. Okay. Now our distance traveled. Okay. So we're going to set the velocity equal to 0 and we're going to solve this equation. When is x to the 4th equal to 3? Ew. Do you want to solve that? No, we have our calculators in our hand, right? How do we figure out where that is 0? We can graph it and find it's 0, couldn't we? Oh, you know how cool I am? I have v of t equals 3 e to the x. Nice work, Sherry. It's definitely t's. All right, where does b of t equal 0? $395? And is velocity negative or positive first? So it goes positive, then negative. So we would have to take the integral from 0 to 2.395 of our velocity minus the integral from 2.395 to 3 of our velocity.